Great to see you here again. We are now starting with lesson 2, the fourth part of lesson 2, and we're still talking about advanced project scheduling and duration reduction. Now we are going to look at the optimization model. In the previous video, I was speaking about the cost-time model, where we found a relationship between the time to complete the project and the cost of the project. Now we're going to look at the optimization model, where we try to find an optimal duration, and here we try to find the duration with the lowest total cost. Now consider a project with an initial duration of 25 days, a total cost of 255K, and a daily cost for the project management, which is 2K, which gives us a total of the 255K plus 25 times 2K, so the 25 days of project management, which is another 50K, which gives us a total of 305K to complete the project. Now, the sponsor only gives us 20 days to complete the project, and there is a fine of 3K per day. Now, we have to add the fine, so we are 5 days late at 3K, and we have to add those 15K to the 305K cost of the project, which brings us a total cost of the project of 320K. Now, this is not so good because we're late and we want to see what we can do about this. Now, let's look at some observations. What do we know about the project? Now, we see that a reduction of the project with 1 day will reduce the cost of project management with 2K. And it also impacts the effect of the fine from 3K to 1K. So every day that we reduce the duration, we reduce the 3K of the fine, but we also have the reduction of the cost. So we have that combined element that we have. Now we must also look at the activities on the critical path to determine what we can save when we are crashing activities. Now, the activities on the critical path that we have in our project is A. A has a crash cost per period of 0.5K, and we can crash this activity maximally 3 days. B has a crash cost per period of 1K. The total crash time possible is 2 days. So those two would give us 5 days that we need. So we have to see, is this sufficient? We also have activity C with a crash cost per period of 3K. We can crash C with a total of 5 days. It's clear that we have to start with the activity with the lowest crash cost per period, which is activity A. And let's say in our case, we don't have any problems with additional critical paths and so on. All the other activities have sufficient slack, so no problem to consider here. It's just a simple example. What are the solutions? Now we look, well, like I said, with the cheapest crash cost per day. We start with crashing A with 3 days, so we have 0.5K per day. We also have the savings of the fine, which is 3K. We have the savings because we have 1 day less of project management, so it's 2K, but we have to pay more for crashing A. A will be more expensive at a crash cost of 0.5K per day, which gives us a total effect of 4.5K per day. So every day we crash the activity or the activity A, the project cost will be reduced with 4.5K. So we have the 3 full days. So we have 330K where we started from, minus 3 times 4.5 brings us to 306.5K, but we are still 2 days too late. Now the next step is to crash B with 2 days, which gives a savings of 3K plus 2K minus 1K or 4K per day. So we have to reduce the crash cost, of course, for B. We can do these 2 days. That gives us a total of 8K that we can save, and we can deduct that from the amount that we already had from the 306.5. So we find 298.5K. So that's basically the effect where we are, the result where we are. And this is the optimal cost, the optimal solution, because we have in fact C, but C is too expensive. It costs 3K to crash C, but we only save 2K. We don't have any rewards if we go faster. So in this case, we have to stop here. We could bring the duration back to from 25 to 20 days. We're within the time slot, and we also have the minimum cost for the project. Crashing more would only increase the cost of the project. We can also have a look at the total cost functions, what we have. So we have the direct cost. The direct cost is the cost to complete the activities. Then we have the different elements, the project management cost, or the cost for the level of effort, which is an increasing function. The longer the project takes, the more it will cost. Then there is the penalty which only starts from a moment where we reach the maximum duration of the project. So from that moment, we see that the penalty with the red line is increasing. And we also have rewards. So the moment that we are below a specific date, we can get those rewards, and rewards will reduce the cost of the project. So when we look at the total cost, we have to look at all those parameters together, which is basically represented in the orange line on the top, or the yellowish orange line, the lighter line on the top, which gives us the duration at minimum cost. So this is the element that we have to consider. We have to find this moment. What do we see here? We still have a penalty, so the crashing could not compensate for the penalty cost, for the loss, or for the reduction of project management. It may be better to go, let's say, to have a shorter duration, but it depends on the conditions and how much is the financial effect on of the penalty on your project. So it would be better if our duration would be between the optimal and the maximum duration, or to the left of the optimal duration. We have to see what the consequences are. Another way to reduce duration is what we call fast tracking. Fast tracking, here we will not reduce the duration of the activities, but we will change the follow-up relationships. Now we look at the different dependencies, and we also considered a percentage complete dependency, and that's what we can use to start working on other parallel activities. The successor activity will start before the completion of the predecessor. It's a very interesting way to start working. We can do this also with leads. We can put a lead that we will start working at an earlier time than originally planned after finishing the activity. Now, the start time of the successor can have consequences on the duration of the activities, but generally it will result in a faster completion of the project. We may have some effects because of fast tracking. Now, what are these possible effects? We have different effects from situation to situation. The activity duration can increase, and the cost can also increase due to interferences between activities. We consider here combined activities in the same location, and there is, of course, a reduction of efficiency due to additional work that may have to be done to guarantee the quality, the good completion, successful completion of the work. Now, there may be some additional risks when the best practice principles are not used. And when we look also at the effects of fast tracking, we also have to look at the critical path activities. When we start doing fast tracking on non-critical path activities, that may not lead, or that will not lead to the reduction of the project. Now, it may have an effect if those other parts are reduced sufficiently so that we get, in fact, more parts, more critical parts than we can work on. So we have to see how the situation is in reality on the project. Now, like I said, we have to identify the changes in the critical path. When we are doing this, we may have a different critical path that appears, and it's very important to be sure, to be aware which path is critical, or do we have additional critical paths. We also look at mandatory and discretionary precedences. A mandatory precedence relationship is a relationship that cannot be changed due to physical restrictions. So, for example, it's impossible to plant a tree or putting a septic tank without first digging a hole. So these are elements that we have to understand. We cannot change the precedence of these activities. We also have to look at discretionary precedence relationships. We call them best practices, and they describe a certain order in executing the work. It may lead to the fact that we are not using the best practices, that the efficiency of the work may not be as good as we expect. Now, when we look at the effect of fast tracking on a project, we have here a project composed of activities A to E. What we're going to do is basically we have here the original duration, and now we put those activities in parallel. So we see activity B already start when activity A is not finished yet. We do the same with activity C and D. Activity E we don't change. Now, when you look closely, you will see that some activities increase in duration. We have to evaluate that. So we have to be sure that we have this effect. It may be that we don't have to increase the duration or the cost, but in most cases it will have an effect. And finally, we find here activity E, the last activity, not put in parallel. It's still the finish to start relationship. And what we see is now the green line, where we have a reduced duration and we have the time saved on the project. And that is what we have to evaluate. What are the effects to see if the fast tracking that we did, if it's really helping our project, yes or no. So this was the last presentation, the last video of our webinar presentation. So that was it. I'm looking forward to seeing you in the next lesson. Thank you and bye-bye.